The first law of functional programming, the most important one that you need to know, is that as the duration of any talk on functional programming increases, the probability that it turns into a talk about how to implement a parser approaches 1. So we're not going to get to that point tonight. I've got 20 minutes. I'll be done before then. I actually know practically nothing about functional programming. I'm just going to read this Medium article to you on the screen. I'm kidding. I'm going to have Siri read it for me. No. This is me on Twitter. Josh Wulf, Cedar Putty. I work at Just Digital People. I'm also the founder of MagicCraft. We teach kids to code in Minecraft. And we set world records, and we use the metaphor of magic. I know, amazing, right? Here's a kid's birthday party that I did in the weekend, and I'm also a legendary JavaScript DJ. Let me give you a bit of a demo here about what it looks like at one of these gigs.
Oh, that's awesome.
It's amazing, huh? Look at that. What's up with that? It's one of those, what is that? No, that thing where it like blocks you from playing something if you have the HDMI plugged in because they don't want you to like copy Netflix and stuff. Yeah, exactly. Digital restrictions management. Anyway, it was a pretty cool video. Just take my word for it. Look me up on Twitter. Okay, so what it is it's the kids programming. They're doing their thing, right? And out of that party in the weekend, we discovered a few things from observing them. And one of the things that we did in the modifications we made is here in our MagicCraft spellbook. Errors. So this is a constant here at the top you can see, and then if I try to redefine this thing to something else, it's going to tell me that you can't do that because it's a constant, so it shouldn't be reassigned, right? But this is like just a design time thing. At runtime, it'll still let you do it in JavaScript. But the whole idea here is that it's telling you about things that you can't do. So that should now go away. And I'm going to paste in another example that I prepared earlier. Let's take this out, these two lines. Okay, cool. Now, let's do that. Cool. So this is actually giving me an error here because we turned this into TypeScript mode. So in the TypeScript mode, it's telling me that this is like not defined. On Saturday when the kids were coding, it was in JavaScript mode. It was like, who knows? It could work. Let's just go with it. And I realized at that point that all of the static linting, type checking and everything, it's all just because 90% of human beings, whether they're 11 years old or 21 years old, can't spell. And so what it does is it checks for that kind of stuff. What a problem trying to have these kids debug that, you know? Like the difference between this one and that one, they just can't see it. The other thing that we did is we changed the braces to being like super multicolored and different because they're just like, which key even is that on the keyboard? Like, and I'm like, just go to your web browser. They're like, what's a web browser? I'm like, Google Chrome. They're like, oh yeah, okay. And then I overhear these kids and they're like, Facebook, that's for old people. And the other kid goes, it's basically like Twitter. I'm like, okay. I don't know what these guys are using. So anyway, the whole point of it is that it's about reducing the different classes of errors that you can encounter, right? And one of the things about functional programming is that it can do away with like entire classes of errors. Like things that just don't happen when you're doing functional programming. And one of the great things about JavaScript is that it is a multi-paradigm programming language. So you can do object-oriented, you can do like an imperative style, you can do functional, and you can use it with types, without types. It's just amazing. It is literally the language of the gods. Okay, so if you want to see some really good things about functional programming, you should go to the Brisbane Functional Programming Group, which is over at Nectar, Data 61 it's called now, over in the valley near Little Tokyo 2. And I'm not sure if Ben is still here. Yep, here's Ben down the back here. He organizes the Brisbane Functional Programming Group. And he gave a great talk about JavaScript and functional programming that was apparently downloaded to a hard drive and has never been seen since. I'm trying to get my hands on it. Immutables. So immutable.js and Ramda. These are two kind of functional programming libraries that you can use in JavaScript. One of the things about functional programming is that, like, I don't know, you could just say basically functional programming, use functions, right? But then there's kind of other parts to it. And it's like a declarative way of describing what you want to happen rather than a stepwise instruction. If you have a look at what Ash was showing us before in that assembly, it's like this very, very low level, close to the hardware implementation of how these things are actually carried out, right? And it's like a very stepwise process. It's like a procedure. And there's this really awesome video that came out the other day. It's this guy who wrote an x86 program in C. He compiled it down to this subset of x86 assembly that's printable characters, so only using the ASCII character set. So it's actually like a printed book that you can read, and it also executes. And he gives this talk, it's about 20 minutes long, on YouTube about how he did that. I'll put a link in the meetup thing. I don't even know what I was talking about. Random, something else. I did take some notes, hang on, somewhere. Okay, purity. Okay, so there's a bunch of different things. So pure functions, that's one thing, right? So I'm using input, which is 2017's font. Fura code, very 2016. Maybe I could make it bigger. I should probably make it bigger. Hang on. Code, insides, preferences, settings. Font size, we'll make it 24. So, that's cool. Good. Functional purity. I went to this talk at NDC by Mark Seaman, and he said that David Hanneman, what's the guy's name? Anybody know? David Hannemeyer. That guy. Yeah. I think he said the best way to predict the future is to implement it. But he also wrote this paper called Test-Induced Damage, and it's about how this kind of way of writing object-oriented code so that you can do unit tests on it, like damages the design. And so Mark gave this talk and he said it's actually the intersection of object-oriented programming and test-driven design that causes that design damage. If you use like a functional style of programming where you isolate side effects and use as much pure functions as you can, then you won't get test-induced damage. So pure functions means that they just take an input and an output. Let me give you like a cool kind of example. We'll go back to the MagicCraft thing. Okay, so this is the classic MagicCraft spell. This is the very first one that we teach the kids, right? It's called jump. And it's just magic.exaltus, and we'll give it a power of 50. Go. Launch this, save the spell. Pretty excited about that WASM, you know, it means that we'll be able to have a Minecraft client that runs in the browser, which is going to be really cool. They can do away with all these installing things on people's machines, and it's just like web browser. Everybody's got one, and then you just start it up. Okay, so this is this function doesn't actually return anything, right? And if a function doesn't return anything, the only way that it could actually do something is if it does what's called a side effect. So if you think of a function as like a black box, things go in, things come out, but sometimes it will do something out the side, right? And what this jump function does is it's just purely side effecting. I don't know if that's actually a word, that's what I call it. I don't know if this will work actually on my phone. Let's see. Join MagicCraft.
There's Wi-Fi.
Okay, I'll see if I can get it to work over the phone. Be lucky. Okay, cool. So here I am on the server. I go near the water, because otherwise I might get hurt, and then I go cast, and I cast my jump spell, and oh, you see that? So it causes a side effect. So side effects in normal programs are things like I/O, writing to the console, you know, like Ash's printf function was a side effect of the WASM, had to get something out. Or was it a return value? No, it was a side effect. Yeah. So that's a side effect, that function there. So to make it into to be able to, let's just say I want to do this, right? So I can add in what's it called, a parameter. Cool. And then maybe I want to give it like a default ES6 in Minecraft, world first. Back to the game. So now, if I cast my spell, I should get 50, but I can also now do up to 100. How's that? Okay, so maybe I want to sanitize the input, right? Because what happens if I go cast and then I go jump and then I just put in like, I don't know, something random like that? Okay, cool. That's pretty good. I wrote an error message in there. What if I put in like a ridiculously large number? Okay, so it just still gives me the maximum size. So what about if I want to do parameter sanitization in here, right? So I want to say something like, if there's no power, we already got that, right? We got the default up the top through that ES6 thing. But what about if it's not a number? So if it's not a number, then I want to set it to 50. So in functional programming, like mutating things is like a real anti-pattern. And even in linting, you can have it set to not allow you to mutate parameters. If you want to start taking on like a functional mindset, one of the first things you do is you get rid of variables completely and you only use constants. And that starts you thinking down a different path, right? So if I'm going to do that, how would I do that I'd have to put it into a function in this case to get that to work. If I'm not going to mutate this variable and I'm going to use it there. So I'm going to have to extract it into a function anyway, so I'm going to do that. Sanitize power, so I put it in here. It's going to take a power and it's going to return a power. Take a power in, and then it's going to return the power. But I'm going to check if the power is not a number. Then I'm going to return 50. And if the power is less than 0, then I'm going to return 0. And if the power is greater than 100, then I'm going to return 100. See? No variables. And now what I can do is in here, I can go const actual power equals sanitize power, and then pass the power that got passed in to my sanitization function, and then I use actual power here. See like that? No variables. Amazing, eh? And then another thing about this is now I've actually got a unit testable function here. Whereas it would have been easy for me to whack all of this stuff like at the beginning, right? And actually, this is the Babel transpiled code. So one of the things that happens in the background while you're coding here, Babel is transpiling this ES6 down to ES5 in the background. Okay. Oh, bummer. What's that? It's a JSON string. So Control C, go back to here, and then I go JSON.parse, and then whack that thing in there, and enter. JSON.parse, and then open single quote, close single quote, this one. Can't get it to work. Whatever. Let me see if I can make it look good for you. So use strict. It's got var function. So if you have a look at what Babel has done, dink. There we go. It's a bit better. So it's actually put like a, in order to transpile this power equals 50 thing, it's whacked this at the beginning here, and it's used a var power, and so it's like, it doesn't actually mutate anything here. It's actually that's actually a constant. But like it's a pretty common pattern to see in JavaScript that you put like your parameter sanitization kind of stuff here, and some of it's type checking as well. So anyway, this gives you, like, doing away with the use of variables starts you thinking down a different path. Let's have a look what else they get. Table of contents, isolate side effects. So I've got my actual power, I've got sanitized power, I've got my side effect happening in here, I've got a unit testable function, so I've separated the testable, I've isolated the side effect into this one function, I've got the testable part in the other one. Referential transparency, no mutation of state. So no mutation of state, if you take on using only constants and never using variables, if you're using Redux, then that's the way that works, right? So when you do like an update of the state, it passes in the state object, and then you do one or two things. You pass back the existing state object, or you create a new state object and pass that one back. But you never mutate the incoming state object. And what you saw with WASM was that it returned like a pointer in memory to a location that contained the actual object. That's kind of how JavaScript passes everything that's not a primitive. So when you pass an object into a function, it passes in effectively a pointer to the object. So when you modify the object inside the function, you're modifying the actual object outside of the function. So with Redux, you never modify that object. You either pass it back without touching it, or you create a new object, cloning it, and pass that one back. And I'll get onto the reason for that if I don't run out of time. Side effects, hidden inputs. So hidden inputs are when your function takes an input from somewhere else, right? Like it could be a random number or a date. And what that does is it does away with the purity of the function, and it breaks this thing called referential transparency. And what referential transparency is that when you call a function, if it's a pure function, you always, if you give it the same input, it will always give you the same output. So, you saw the sanitization function, referentially transparent, pure function, no hidden inputs, nothing coming in from places you can't detect, nothing going out where you can't detect it. It means that it's deterministic, you can unit test it. There's quite a famous kind of story around Brisbane of some consultants who went to a pizza place and they were, helping them to build their CI pipeline and everything. They had all these unit tests, it was all great, but every Tuesday, a bunch of the tests would go red. And they just couldn't figure out what it was, and it was, of course, because of the day of the week, and Tuesday's cheap pizza day. And the way that the code had been written, the tests would fail, because these functions that they were testing were taking an input from the date, the time that they were actually run at, and that would change their behavior. So referential transparency means that your function doesn't change its behavior. And I'll show you what you can do with that, right? This is a thing called memoization, just at a high level. So let's say you have something like, employee pay table. And it takes a bunch of employees, and it takes, time and data sheets, Tanda sheets. And does magic here, and then return epic result object. Okay, cool. And also, one other thing to know about this is that it takes, 20 minutes to run. Okay, so here's what you can do. If this is referentially transparent, if it's a pure function, you can do what's called memoization, right? Which is this, that if I know that the last time that you called this function, employees, was, I don't know how you draw this like this, some employee object, and I know that the Tanda sheets was some Tanda sheet, and then what I do is I just store the epic result object. The next time you call the function, if you call it with the same inputs, I know that the output will be the same, and I already have it. Does that make sense? This is called memoization. This is why you hear people talk about functional programming, and they go, functional programming makes your code easier to reason about, because you can make assumptions like that. You know that if you call this epic function with the same inputs, it'll give the same outputs, so you can memorize them. It's called memoization. It's good for like Redux, when you're working with Redux, and it's kind of how the whole React thing kind of works. Here's a couple of basic functional kind of things. How am I doing for time? I'll just go for another 2 minutes. I'll show you a couple more things. So iterators. So another thing you get rid of is iterators. You saw that C code there. It's pretty old school. Let I equal 0. One of the cool things about this is that now that we have let, you don't end up polluting the global scope when you create these iterators. Before you do for that, and it would put that I into the scope, which would mean that it would still be here. So you could console log I outside here. It will give you something. A equals zebra, cow. So you can see I still exists outside, whereas if I go let, hey, don't you love the way that my code runs in the browser while I'm typing it? Amazing. 2017, baby. So this is an iterator, right? I'm going to do some side effecty thing in here. I'm going to actually log out this thing like that. There they are, zebra and the cow. So that's kind of like a C style iterator. So the way that you do that in a functional style is you do this. A for each, and then I'm going to pass an animal into console.log, the animal out. Like that. This thing can't execute that for some reason. Doesn't have a deep functional thing going on. But if I do So that's how you do it in a functional style. So there's a few things about that. There's no iterator, there's no kind of off by one errors or anything like that. You'll be surprised actually how many people will do some weird thing like that or whatever. It just iterates across the objects and does that. And if you want it to return a transformed, like we can do this. I don't even need to return it. I'm going to do, I'll make all the animals blue. Animal. So if I then make that into a constant, because var or let are old school, there we go. I made them all blue. And so what map does is map will iterate across your collection in an array and it will return the transformed versions. And if you want to remove things from the array, then you've got to use filter. And so if I go const c equals a.filter, so let's say let's put some other animals into this thing. Put a pig, and we'll put a dog. And made them all blue. I'm going to do this. So I'm going to go const colors equals, I don't know, red and green. And then I'm going to go, as I'm mapping across these, I also get an index in here. So instead of doing that, I'm going to do colors, I modulo 2. Put that inside these string templating things. Thank you. Cool. So if I'm going to filter them, now I'll take the animals, right? And then I'm going to return true if the so animal dot index of red does not equal -1. Oh no, it doesn't have ligatures. Anyway. Cool. There you go. So filter, if you it maps over, it goes over your collection, and then if you return true, it'll add that thing to the collection. And then there's reduces the final one out of the 3. So if I want to do a reduction on these things, I would do. You know, I've got a good idea about reducing the animals. Make it into a stew. So we should call it animal stew. So I'm going to reduce the original one, the A. I'm going to reduce that. So reduce. And then what I do is I get the previous value and the current value. And then I'm going to, what would I return for something that will make a nice stew?
Join together.
Yeah, it's kind of boring, but whatever.
If you want, get the key code of every single character, get the char code, and add the number,
Emojis?
add the number together.
Turn them into emojis. Okay, so previous, and then I want to add the current one to it as well. So we'll just add this one. Turducken, yeah. There you go. So there's an animal stew. It's turned into a single type of. String. So turn that array into a string. So that's reduce, map, reduce, filter. So those are kind of like basic functional building blocks. They make your code a lot easier to reason about, and you can, because they're composed of functions, you can do lots of different things with them. So this is just kind of like an introduction to it. The reason why functional programming isn't kind of as widespread as like the other styles of programming, I believe, is because it's at a much higher level of abstraction. Like if you look at it, that WASM thing is almost like the instructions that the CPU will do. Then you've got like C, then you've got like this object-oriented language, then you've got functional. So let me give you an idea of what that looks like. Here's some tests that we ran. This is fast array for each. So this is like comparing a C-style iterator with array for each. And if I run the tests, it's going to show you how long it takes to run each of them. That's running the iterator. If that gives you an idea about the performance in JavaScript. Like the C-style iterator is like 900,000 and this one's like 36,000. And here's another test, 4 versus map. I think we did an even bigger test, it's like 20,000 elements in the array. I think it was last BrisJS when I was here, someone said to me, what you do is you set your Babel or your TypeScript transpiler or whatever you're using to transpile your code down to ES5, and it will take out all of these, or maybe you'd have to do it to ES3, I don't know, to get rid of that stuff. So 43,000 ops with the iterator and 280 ops with the functional stuff. So you kind of got to be careful about how and when you use it from the performance impact side of things, but it does, once you start thinking functionally and doing away with vars and like these kind of tricky kind of stuff like this, it does away with an entire class of errors, especially when you do away with variables. Variables, once you do away with them, you're like, actually that was like one of the biggest sources of problems, was variables. And then you go back and look at performance. As Corey spoke at the last one, was it? When Corey spoke, he said, your computer's really fast, so don't worry about optimizing for speed. And then like the very next slide is like, your computer's really slow, you've got to optimize for speed. So it's like, you got to figure out when to do each of the two things. This is Quokka.js, made by the guys who made Wallaby.js. Duncan Hunter showed that thing here. It executes the code in your IDE while you're editing it, which is really cool. I'll put some links and stuff up on the meetup.com website for you to check out for Immutable and Ramda and that kind of stuff. And I definitely recommend checking out the Brisbane Functional Programming Group. And one last thing is that we've got a hackathon event on this weekend at Fishburners, Friday, Saturday, Sunday. If you're interested in coming along, we're just going to be hacking on JavaScript in Minecraft using the web browser. So if you want to get into some of that, you're more than welcome. I'll put a link to that in the meetup group as well. Thanks.